Hello everyone, welcome back to Ruby Lessons and Code Academy. In the last lesson we looked at classes and why you would want to separate different methods from each other or from public access and private access. We also looked at the attributes writer, reader and accessor. Today we're going to be looking at modules. So what is a module? You can think of a module as a toolbox that contains a set of methods and constants. There are lots of them in Ruby and in other programming languages, not just in Ruby. I don't think that they're all called the same, and I'm pretty sure that for all languages they can be different, but they can be also similar in a way. It really depends, you would have to look it up. You can download extra modules, I know that. They're sometimes called libraries, so let's just move on. But if you use all of them at once, they will clutter the interpreter to keep them all around all the time, and they can waste efficiency for that reason. So that's why we keep a bunch of them in modules and only pull those module toolboxes when we really need those. So you can think of modules as being very much like classes, only modules can't create instances and can't have subclasses. They're just used to store things. So instructions, check out our example module in the editor. It has an approximation of pi stored in pi capitals and a series of methods for calculating the circumference and area of a circle. So this is a custom module. And what? Oh, okay, that's weird because I ran it twice. Fair enough, whatever, it doesn't matter. So that's just an example of a module. It didn't have anything running because we hadn't called any of its methods on anything. So module syntax. You can pull in pre-existing modules. We'll show you how soon, but you can also make your own modules. I will call them custom modules because they're your own and they're in custom in a way. Modules are super easy to make. You just use the module keyword like so. And the definition looks quite similar to a class, as you can notice. So, like class names, module names are written in capitalized camel case rather than lowercase with underscores. It doesn't make sense to include variables in modules since variables by definition change or vary. Constants, however, are supposed to always stay the same, so including helpful constants in modules is a great idea. Such as in the example that they gave us, having pi, because pi is a constant. And please don't change it to 3. Ruby doesn't make you keep the same value for a constant once it's initialized, but it will warn you if you try to change it. So Ruby constants are written in all caps and are separated with underscores if there's more than one word, to show that there are more than one words. So an example of a Ruby constant is pi, which lives in the math module. So if you wanted to call the math module, we will look at that later on. And is approximately equal to 3.142. I'm just gonna say that. We created our own pi in the previous exercise, but don't worry. Because they're in separate modules, Ruby knows to keep them separate. So instructions, create your own module called myLibrary. In the editor to the right, include a constant called favebook. Okay. And set it equal to a string naming your favorite book. Is there a specific way to make a constant? My favorite book. I don't really have a favorite book, but the first book that pops into my mind is... I really hope I'm spelling Robinson. Is it Robinson Crusoe? I hope I'm spelling it correctly. It doesn't actually... Yeah, I didn't see a constant variable definition. In C++, you have to say that it's a constant. And the fact that here you don't have to say it is kind of annoying, but oh well. Moving on. Resolve to keep learning. One of the main purposes of modules is to separate methods and constants into named spaces. So this is called namespacing, and it's how Ruby doesn't confuse math.py and circle.py. So those are two different things, and they will be stored in different parts of memory. So see that double colon we just used? That's called the scope resolution operator. So pi, this pi belongs to circle, this pi belongs to math. Which is a fancy way of saying it tells Ruby where you're looking for a specific bit of code. So if we wanted to get pi for math, then we do math double colon pi. And if we wanted to get it from circle, well, we do circle double colon pi. So in the case of math pi, Ruby knows to look inside the math module, instead of the circle module or anywhere else to get it, not any other pi, such as the one we created in circle. You can also have a global variable named pi, and by using this, it's going to specify that you want it for math. So let's get some practice in with an existing Ruby module, math. Instructions: use the scope resolution operators to put the value of pi from the math module in the console. That's all it means. There we go. And we get the constant of pi to however many decimal places that is. 3, 6, 9, 12, 15 decimal places. And that's probably enough for most calculations. A few requirements. So some modules like math are already present in the interpreter. Others need to be explicitly brought in. However, we can do this using require. So we can do this simply by doing require and then the name of the module. We want to use Ruby date module to show today's date, but we haven't required it yet. So how do we do that? Well, we do require and then date in that on line 1. Is it not supposed to have the quotation marks? Convert class into string. Okay. So the naming is kind of confusing. If you're doing require, you have to name the module in all lowercase and put it in single quotation marks. But then when you are using it, you have to do the first letter as uppercase and then .today. If we run it now, as you can see, today is the, I don't know if this is the American or okay, so it's the 4th of the 3rd of 2017. So it's the 4th of March, right? No, it's the 3rd of April, not March, because it was April Fool's a few days ago. So yeah, it's the 3rd of April of 2017, the day I am recording this on. So let's move on. Feeling included. We can do more than just require a module, however. We can also include it. Any class that includes a certain module can use the module's methods. So a nice effect of this is that you no longer have to prepend your constants and methods with the module name. Since everything has been pulled in, you can simply write pi instead of math pi. So yeah, you can just, basically what this means is you can just leave out this part. But in the case of you including the module circle and math together, in that case you would have to all prepend them with whichever one you're using, if they have the same name for a certain variable such as pi. Instructions: in our case we want to use math cos, but we don't want to type math. Please include math on line 2. So include math. And there we go. Where is cos used anyway? Ah, there we go, cosine. And that is going to be it for today's lesson. Modules are quite interesting because they come in quite handy if you know which module you need to use for a certain thing. So if you're doing a mathematical operation, then do try to look in the math module. Sometimes I know that in C++ you have to include the string library actually. I'm not sure. Modules and libraries are kind of similar. But yeah, you have to include a module to be able to use string methods and strings. And here you need the math. So yeah, they can be quite useful if you know where to get them from. Sometimes you do need to search them up, sometimes you need to download them, as I did mention. If you enjoyed watching this video, please give it a thumbs up, share, like and subscribe. It encourages me to make more videos such as this one. If you didn't like it, then please tell me in the comments down below why you didn't like it, and do feel free to give me a thumbs down. I don't mind as long as I can actually improve for the next video. But until that next time, thank you so much for watching and goodbye.